Welcome back everyone to another video, and in this one we'll be taking a look at kPatch or Red Hat's implementation of live kernel patching. Now in a Linux based operating system, pretty much anything except for the kernel can be upgraded or updated without rebooting the systems. Modules can be reloaded, daemons can be restarted, and pretty much every other program can be stopped or paused and then updated and then restarted. So you don't really need a lot of downtime to upgrade a Linux operating system as such. But with specific kernel updates, since the kernel is just a single binary package, you can't really do anything. You have to reboot it until now. So kernel Linux kernel 4 provided us with a stable build and a stable implementation of live kernel patching. That meant that certain parts of the Linux kernel, especially related to security and stuff like that, can be patched live without rebooting the system or without stopping it for more than a few milliseconds. So, live kernel patching, the live file patching part, it has been done on the Linux kernel side, but it still has to be implemented from the user land. And Red Hat's solution to that is called kPatch. Now, kPatch is actually one of the main programs that will be driving this feature forward. Apart from that, we do have kgraft, but that is very specific to SUSE OS and OpenSUSE and not on other operating systems. So, for example, kPatch runs on Fedora, Red Hat 7, CentOS, Ubuntu, Oracle Linux, and Debian as well. So, what we have to do is first of all get a compatible operating system running. Now, since this is just a test, I will not be using my main system, my Ubuntu machine. What I'll do is fire up a CentOS VM, and then once it's up, I will connect to it using SSH, because this is sort of a small terminal to work on. So I'll use SSH to connect to it and communicate with it. Alright, we are in. So just to show what exactly I am running here, I have a CentOS 7.3 release on a 3.10 Linux kernel. So even though it is still 3.10, it has the live patching built in. So on the kPatch GitHub page, it is very well documented how you can get started with it. So we'll follow exactly the same steps, and I will actually demonstrate how all of that works. So first of all, we need to get the exact kernel version into a variable. So we'll take it into uname, then install some dependencies, and that should install our dependencies for kPatch. So this is just for the kPatch command and not the kPatch build command. So the kPatch command basically loads everything up and manages all of that stuff, whereas the kPatch build command is used to build the whole modules. So we'll just wait till that gets over and I'll get back. Alright, so with one of the dependencies for kPatch installed, it's time to do the same for kPatch build, and we will be actually pretty much doing the same thing. Alright, so with that done, we now need to install a very special package which actually has to be enabled in the package manager first, and it's called the kernel debug package. And what it does is, apart from many other things, it does provide a lot of debugging tools and stuff like that, which kPatch uses to actually compare what patch has been applied to the kernel and then create a live patch. So we'll be getting a bit more into how it does that and how to make that work. But first now we have to install these packages, and I think I'll get back once we are done. Alright, so with all of the dependencies installed, it is now finally time to install kPatch, and I will be building it from the kPatch source. So first of all, we do need to clone the source, so that would be git clone and the kPatch URL, and that shouldn't take too much time. It's not that big and it's done. So cd into kPatch directory, uh, and then simply enter the make command. I'll have J2 to make things faster, and that should be done just like that. So it's not something really complicated to compile, and then of course install it for easier use so that you don't have to refer to the kpatch directory over and over again. So sudo kmake install, and that would install kpatch. And now we have our kPatch user land stuff installed. So kPatch is the kPatch list gives us a list of patched modules installed. So we don't have any installed yet, so it's nothing there. And then there are load and unload stuff, what we'll get into further on. Alright, so the next step is, first of all we will create a working directory for our kPatch stuff, and just simply name it kPatch stuff, and cd into that later. And what we'll do is, first of all we need to have a dummy patch file, and the reason for that is the patch file that is provided in the demo is not the same that would be used for our particular kernel source that I have tested a couple of times. So first of all we need to create a dummy patch file. So let's just name it that, and regardless right now of what the patch file does, we'll just create one and then issue the command kpatch build and vm linux, and then the patch file name. So this will actually make the kpatch build command download a proper source for our current linux kernel, and that would actually enable us to then create a patch file based on the proper linux kernel source. So while we are waiting for it to download, alright, so we are back, and as you can see it does say error source patch failed to apply, and that is because it wasn't the correct patch. So we will have to create a patch. Now before we do that, I want to show you what change we are going to make by applying the patch and what change is going to be reflected. Now since this is sort of just a demo, I will not be showing you any actual patches that would change the underlying code, rather than I would just show you something that is a bit more visible. So what we'll do is um, so this is the output that we are going to change. Now proc that now this command may seem like it's just spitting out a file from some text from a file, but it is actually, since everything is a folder or a file in the Linux file system, it is actually calling a function called meminfo proc show to display these values. And what we are going to do is change the vmalloc chunk into maybe let's change this into completely capital, like it's being done in the patch. So instead of vmalloc chunk, it would be capital V, capital M, capital A, and so on and so forth. And that should be our change. So since it is a function that is being called from the kernel, what happens is you cannot just change the file and it won't reflect or anything like that. You will actually have to go ahead and change the binary and then traditionally reload the kernel by rebooting the system, and then this change would take effect. But now since we are using kPatch, we can demonstrate it, and we can demonstrate it taking change live. And to do that, first we have to create the patch. So we'll go into the source directly for kPatch. Now this is not the recommended method of doing things. The recommended method is that you have a separate a source file, and then you do changes there, take the patch from there and then apply it. But just to keep things simple and short, what I'm going to do is make the change directly at the kPatch source file. So cd and then home.kpatch, then source, and first we have to go here. Now you can see this is the Linux source. Now this is not initialized by a git directory, so what I'll do is git init, and that would initialize a git directory. So you can see my .git folder somewhere. Yeah, so you can see the .git folder right here now. So it is now a git directory, so I can create a git patch, a git format patch. And what I'll do is first create my initial commit, and that would be git add all, and then it will take some time because there are a lot of files. And then once git add is done, simply git commit m and then like something like initial commit, and that should create a commit, and it will take some time. And alright, so now we have initialized our repository on git. We can check our commit log and we can see we have the initial commit right there. And then now we can go ahead and make our changes to the repository, and we will be changing of course the meminfo.c file. And let's just find our line to change. And there we are. So we have to change the VM alloc chunk. We can change anything, so we'll just change that. And instead of just going to a full capital, what we can do is completely change the string. That's what I actually want to do, just to play around with it. So let's go ahead and go like VRT MEM and ALLOC and then CHUNC. So virtual memory allocation chunk, and seems about right, should work. And just exit it and then create a new commit. So git add and then git commit memalloc change, and that should have it reflect on our git log as well. Now we need to create a patch. So for that, so git format patch and -1 and head, and then we have the patch name. So let's just go with mem alloc change.patch, and that should have our patch. Now we can cat that patch and see what it looks like, and see of course delete the vmalloc line and add the long string virtual memory allocation chunk string. And with that, we need to do one thing, is we need to reset our source, and that is because kPatch initially builds the original source and then rebuilds it with the patch. So that means we cannot leave the source as it is. So what we'll do is again git log and then check out our original commit. So git check out, and then our initial commit, and we have we are now at that commit. So if we go to our file and then so you can see that we are back to VM alloc chunk, but now we have that patch and we can apply that patch using kPatch. So first of all, what I'll do is copy that patch to my kPatch stuff folder, and then cd into that folder. So now we have the two patches. We can remove the dummy patch now and rm, and there we go. Now we can finally start the build process. So for that, we'll again use the kpatch build command, and T is VM Linux. So what kind of binary do we need? So VM Linux is the full uncompressed one. We have Z image, we have V M Linux, which are both sort of compressed Linux binaries. So kpatch build T VM Linux, and then our patch file, and then it will start. It has tested the patch file. It seems okay to it. Now it will actually start building the original source, and then finally the patched source. So I'll leave it here and come back once it is done. It is a bigger process. Alright, so we are back with the patch module built. So let's go through the steps. So it started with building the original kernel, and then it built the patch kernel, then created a difference or a diff function, and what it did was it extracted a modified. So what it did was it basically kind of subtracted both the modules, and whatever the difference in them was, it then changed it into a patchable object, which now we have as a patch module called kPatch 001 malloc change.ko. Now here we have that module, and what I'll do is go ahead and load that module, which is as simple as sudo load kPatch load and the name of the module, and that would load our module into our system, and it's as simple and as soon as that. So we can go ahead and cat out our function. So cat proc meminfo and grep v. So now instead of VM alloc chunk, we have virt mem alloc chunk, and that is the change. So again, it is calling that function, and instead of going directly, it is actually going through a bit of process and then giving out the patched function. So I will take the liberty of showing from this particular video a very nice flow diagram what we have here of how things happen. So before patching, when you call a function, it would just return the value whatever it needs to return. But after patching, what happens is there is a separate part in memory where the patch resides, and when you call a function, it goes to another function called ftrace or function trace, which then communicates with the kPatch module, which tells it where in the memory is the newer patched function, and then it will return that to the memory block it wants to go. Then we have our replacement function residing there, which would finally return our patched module. So this is how all of it is actually working behind the scenes, but it is so quick and it is actually very effective without any loss in performance. So what now we can do is unload the patch, so which would be as simple as kPatch unload, and now we can actually go ahead again and it has reset to its previous version. And let me load it once again, and then I can do actually kPatch list, and that would give me a list of the modules that are loaded. So in this case it's kPatch 001 memalloc change, and this is loaded, and then we have our other stuff. So this was it, more of a visual demonstration more than anything useful. But what I'll do is I will actually at the end right now show you all a video where it's by Red Hat themselves, and where they actually show a very usable patch being a very usable patch being implemented, and that is actually how an end user would do it. Now an end user will not have to go through the process of compiling everything. They will get it directly from their OS distributor, so in this case Red Hat, and they would provide with the patch. So I will put a very small snippet at the end. So I hope you have guys all enjoyed this video. Thank you so much for watching, and I will see you all in the next one.
So what I have here is a RHEL 7.1 beta machine. And it's running the 2.10 version of the kernel. This version of the kernel was vulnerable to a particular CVE, and I have the program that exploits that CVE called test case here on the system. So it's a denial of service exploit, and so when I run this, it will either hang or crash the machine. So I'm going to sync my file system to reduce the risk of corruption here, and then run the test case. Oh, and you can see that it crashed the machine and it's rebooting here. So in the event that a CVE like this is exposed, Red Hat will create a kPatch module and then deliver it through the kPatch mechanism. So from a customer side, what you would do is do yum install kPatch patch. And what that will do is install the kPatch patch and package and the kPatch package for the command line utility that's going to manage these hotfixes. There's a delay when installing the kPatch patch package because as part of a post-install hook, it's going to install the hot patch modules into your init ramfs. That way the patch is applied as early in the boot process as it possibly can. It can't become part of the kernel image, not without a reboot. But if you do reboot into the same version of the kernel that's vulnerable, these hot fixes will be applied as soon as possible. So now if we do a kPatch list, you can see that we have a kPatch module installed for this kernel version, and it's currently loaded into the kernel. And if you look at your kernel log, you can see that a kPatch has been loaded. So now if we run the exploit, you can see that it doesn't crash the machine and it doesn't hang the machine. It seg faults like it should, which is great. We didn't reboot, and we've closed the CVE fix, and we've closed the CVE exploit. So now what we can do in the normal workflow, what you would do is then install the version of the kernel that isn't vulnerable. I have the RPM locally here. We'll just install that kernel version. Almost there. All right. And then we can, so then the workflow, the system is no longer vulnerable. You've got the kPatch applied. Ideally, what you'd eventually like to do is reboot into a kernel that doesn't have the exploit. And so you can install the kernel at any point, and then during your next maintenance window, or the next time you can schedule any downtime, you can reboot. And this will boot into the new version of the kernel, which isn't vulnerable. And then if we run the exploit here, we get the segmentation fault like we should. And if you do a kPatch list, you can see that the module for the old version of the kernel that we were running is still installed, but there are no patch modules loaded for this kernel version that we're running. And then if a CVE comes out for the version of the kernel that we're on, then that will be included in the kPatch patch module. The version number on that package will rev, and when you do a yum update, it'll pull down the new hotfixes for the kernel, for any kernel version that you're running.